Here we're supposed to graph the solution set to this nonlinear system of inequalities. Notice the first inequality is a quadratic. Notice down here the two choices for drawing a quadratic both involve finding the vertex. Then we'll have to find a second point on the parabola to draw its graph. Since this is missing the linear term, the vertex will lie right along the y-axis, which means the vertex and the y-intercept is one and the same. So to find the vertex in this problem, it would be sufficient simply to replace x with 0. Replacing x with 0, you would get a y value of 2. So it turns out that the y-intercept, and in this case also the vertex, is 0, 2. It is interesting to point out that if the linear term had not been missing, you could have used the formula negative b over 2a to determine the x value of the vertex. But because the linear term is missing, you could think of it as the b value in the formula would be 0. Plugging 0 in for b into this formula would give you x equals 0, since 0 divided by any number is 0. That would have led you to the same result that we got before. Once you have the vertex of the parabola, we can find any other point that lies on this grid. So far we've already plugged in 0 for x and found that y is 2. I need to find one more point. Notice you may want to avoid plugging in something like x equals 1 to avoid fractions. At x equals 1, this part of the equation comes out to be a half. So to avoid fractions, I'm going to plug in x equals 2 to get a y value that would be 2 squared is 4. Half of 4 is 2. And then if we add 2 more, I get 4. Let's go graph this. Because my inequality is a strict inequality that y must be greater than, as opposed to greater than equal to, this algebraic expression, I'll choose the parabola that is dotted. First, I'll click on the vertex of 0, 2. I'll move to the point 2, 4. Click and let go. Now I have to choose either to shade above the parabola or below the parabola. Because the y values in my solution set must be greater than the y values of my quadratic, I will pick a point that is above any of the points that I used to draw the parabola. Next, I have to draw the line y equals negative 1/4 x minus 1. First, notice that it's a strict inequality. Y must be less than, as opposed to less than or equals to, this algebraic expression. So when I go to graph my line, I will choose the dotted line. I'm going to start by graphing the y-intercept of the line, negative 1. I'm going to use the fact that the slope is negative 1/4 to get another point on my line. Since the slope is negative 1/4, I'm going to go down 1 and to the right 4 to find another point on my line. As with the parabola, I have to choose to pick a point above the line or below the line to shade the part of the plane that's part of the solution set. Since I want the y values of my solution set to be less than any of the y values of the points that I use to graph the line, I will shade below the line. It's important to note that the solution set to this nonlinear system of inequalities is the place where the two shaded regions intersect. Because there are no points that are both above the parabola and below the line, the solution to this system turns out that there actually is no solution. There is no xy pair that satisfies both the first and the second inequality.